All right, so I think we are ready to kick things off now.
Okay. So good morning, everyone. Thank you for joining us on the Saturday morning. My name is Nihal Kashinath. I'm the founder and CEO of Applied Singularity. For those of you who are attending one of our sessions for the first time, we are a platform for deep tech professionals. We help bring together deep tech professionals for learning sessions such as this one, and also to help you guys find interesting jobs and careers in this space. So today we have a very interesting session. This is actually the second part of a two-part series that we started about 2 weeks ago. In this session, we're basically going to look at graph databases and all the wonderful things that you can do with it, specifically from the context of IoT and supply chain. We did have a very good session 2 weeks ago, which kind of was the first part and covered a lot of the things, but no worries if you missed that, you can still kind of catch up. In this one, we will cover some of the basics before we get into the details. And like with the previous sessions, it's a lot more Q&A focused because we did see that many of you guys are in some sense already power users, or you have specific use cases, and it's I think the Q&A part actually also led to a lot of great learning for everybody involved, just looking at each other's use cases. So I'll keep it short. And for those of you who haven't used our app before, we do have the Applied Singularity app available on both iOS and Android app stores. It gives you a lot of content related to Internet of Things, artificial intelligence, and bioengineering, research papers, articles, jobs, events such as this one, and of course, a lot of videos and courses, a lot of good learning material. So please do download that. And a quick reminder, today is actually the last day. So we've recently launched this job search support program, especially for those of you who have started to build up your skills in the AI space, but have not yet found your ideal jobs. We are actually helping a limited set of people to start. It's just 20 people. We are helping you find those jobs that you are specifically looking for. It's a free program. Of course, it's more of a community support initiative. But because we are doing it for the first time, we're limiting it to only 20 seats. And if you're interested, I'm anyway going to post the link to that form here, the application form. Please do feel free to fill it out after this session is done. Okay, great. And so with that, I will hand it over to Daniel, who will take us through what TigerGraph can do for IoT.
Great. Thank you very much, Nahil. So today I'm going to start, we'll cover a couple things. We'll quickly go over a brief recap of what graph databases are. We'll jump into some of the ways in which graph can benefit a lot of the common IoT use cases. And then from there, we'll take a look at what a IoT schema might look like in a graph database. So let's get started with just the brief graph overview. So what are graph databases? Just a different way of storing your information. Whereas a typical relational database, you have tables with rows of individual data entries and columns, which each represent an attribute of that data. And when you want to query all of your data at once, multiple tables, you have to write these joins into your queries to try and find the aspects from one table that relate to another table, the primary keys and foreign keys, in order to join those together to get the complex results from your query. Whereas in a graph database, all of those joins are more or less pre-computed by edges, which naturally express the relationship between the different types of data in the database. So very quick example here, we can see a relational database. You might have a table for a product, which would have a bunch of different products and their attributes like their cost, maybe their name, any other specific information about that product. You might have an order, which then has a list of the same IDs of those products, but it has some other information about them as well, maybe the time the order was placed, things like that. So if I want to then see which customer placed an order and find out what products were in that order, I now need to jump between these three tables. I need to join them together. I need to look for the primary keys of that order ID, of those product IDs, join those tables together and get those results. Whereas in graph, when you load in the data, you would say, I loaded in this order was made by this customer, and this order contains these products. So that relationship is already there within the graph. So that way, when I say, find me all the products that this customer ordered, it just traverses that relationship chain much more naturally and much more efficiently than having to write out those joins each time. The whole kind of concept is if you pre-compute this, you only have to do it once versus having to compute it every time you execute your query. So you can see already how that's much more efficient when finding these complex relationships. And in addition, it also allows you to store much more relationships than you would be able to store in a traditional database because it's so oriented around those edges rather than having to make those edges when you need them. So just to kind of add a little bit more info on graph, the specific type of graph that TigerGraph is and that most graph databases are property graphs. So that means that each one of these vertices, so a vertex represents a data, idea of data, more or less. Think of it as analogous to a table. It would contain something like a payment, but that can have attributes, which can then further describe that payment, the amount that it was, the payment ID, or any other information. Orders, again, these are vertices can have attributes as well as these edges. Edges can also have attributes. So something like this order was, this payment was accepted for this order, and the edge stores the date time that happens at, because the date doesn't really pertain to the payment or the order, it's the relationship between them. When was the order paid for? So that's why you would want to maintain an attribute along an edge like that. So that's a very high level, quick overview of graph. You'll get a little bit of a better understanding with some of the graph examples later on, but I'm just going to jump into use cases. We've got a little bit of stuff to cover. So I'm going to move through it quickly. The kind of core IoT use case stems around the idea of a digital twin. So a digital twin is essentially just a digital representation of something physical in the real world. And that will vary based on what your use case is. A lot of the time in industry, it would be a piece of machinery. So a tractor, for example, or a piece of manufacturing equipment, a press or a molding machine that would have all sorts of different parts in it that you need to maintain. You need to have insight into the status, the wear, and the potential failure points of those parts. And in order to do that, you need to keep track of that. You need your sensors, you need your IoT, your typical IoT bread and butter in order to do that. So what that allows you to do is by having that holistic view of any particular device or piece of machinery, you can more easily predict when it's going to fail and provide preventative maintenance to prevent it from failing. You can make sure that other pieces of your manufacturing pipeline are able to pick up for it, for the downtime that might be there for the failure. So it just allows you to start planning ahead by being able to see sort of more granularly the status. But that's great and all, and that's kind of the IoT view of it, but where does graph come in there? Well, all of these things have relationships to each other. Maybe the vibration of a machine is related to the wear of the motor in the machine. And that might not be immediately apparent, but when you have a bunch of these machines and you're collecting data from all of them and you're linking that data together with graph and you're saying, these machines are running this much for this amount of time, and this machine is producing this much vibration, and now this machine is starting to vibrate more. Well, we can assume that because the one that was vibrating a lot failed after a couple of weeks of doing that, that this one that's starting to do that now will also be going to fail. And once you have that visibility in your pipeline, you have the ability to now project how much downtime you're going to have, how much product you're not being able to produce during that downtime, because all of that information is maintained sort of within that supply chain, that that graph of connections between those devices, their sensors, the things that they produce, all of that sort of stuff. So digital twin is kind of going to be the core use case, and whatever that twin is really is dependent on the industry where that is. But a lot of the IoT graph use cases do stem around getting that holistic view by linking together a series of sensors or a series of devices to see how they interact with both what they are producing, what they are consuming, and with each other. So one big one is healthcare. IoT in healthcare is a huge upcoming trend, something that's been increasing for years, something that's been around for a very long time and is only becoming more and more prevalent. So if you really think about it, healthcare is a great use case for graph because the healthcare system is a series of touch points. You go to a doctor, you go to a hospital, you go to a clinic, you get a lab screening. All of these areas that you interact with, each one of those are a unique vertex in your graph that you're interacting with, and your edge connecting them stores the information of when that happened. And the thing itself stores the information of where did you go, what doctor did you see, what were the results of your test. And now by being able to link all of those different interactions together, you can get this holistic view of a patient that we just weren't able to see before. So now you have much more information about, this patient went to this clinic and was diagnosed with this disease and then went through this series of treatment, and that worked out well for them. So another patient who is going through a similar situation, we can recommend that same care path, and we know that it will have a good outcome for them. But where IoT really comes in there is the wearable technology that has been getting cheaper and more accessible over the years that allows us to now more or less have 24/7 real-time heart rate information, blood oxygen information, and all sorts of other biometric information depending on the device that you're using. So you now have a much better idea of how the daily activity that a person goes through affects their health. So now it's not just person went to clinic, person was diagnosed with disease. We can now see what happened in between. What did their health look like in between? What did their weight look like from their smart scale? What did their heart rate look like day to day from their Fitbit? What other information do we have from these IoT devices that people already own? From their smart door lock, how often do they leave the house every day? From the GPS on their phone, how far were they walking? Information like that, which can all contribute to this much more holistic view of a person's life. And again, this is a digital twin that we're creating of a person. This is a representation of that person from all the digital information that we have, all those assets that we can use to now gain further insights into what is going on. So that's kind of our digital twin for the healthcare marketplace and what that looks like with IoT. And another big area, of course, is once again, going back to supply chain. Everything goes back to supply chain because it really is the backbone of our modern industrial world. And IoT is, of course, appearing a lot and has already been in supply chain for a long time, and only opens up the opportunities now to really bring in all of those connections from that data that's being generated by your supply chain into a graph to get that more broad view of how everything connects. So there's obviously tracking information is something that has been available for a long time. So GPS information, trucks, boats, planes, that's all pretty standard nowadays, but that's all still information that can be consumed. Environmental data. So this is things like cooled shipping containers or climate controlled trucks, things like that may be shipping produce or other goods. How do you guarantee that at no point during transit did that truck rise above the temperature threshold set by whatever Food and Safety Administration is in control of the food? How do you guarantee that that food was safe for its entire journey? Well, with IoT and with the ability to monitor that temperature, to log that data and store that, well, now you have the ability to say, this food was kept at this temperature for the entire duration of its transit. You can guarantee the freshness of your product. And then again, like we were talking about before, consumer smart goods, your smart doorbell, now it's able to confirm back to the person who shipped you your package that it was delivered. Not only do you have that endpoint of the delivery person saying it was delivered, but you have that full chain of, essentially the house saying this package has arrived here, and here I have this picture of it sitting on the front porch. So it's very interesting to kind of see how that IoT connection is really allowing this supply chain to become more and more of a digital supply chain as well. We're able to create it with that information, that real-time IoT data that we are collecting, create that digital twin of a supply chain. And again, once you have that digital twin, you can forecast how different things will affect it. How will changes to this part of our supply chain affect the rest of it? How will adding new suppliers to this end of our supply chain, will that be more than we can handle in these other areas? You now have the ability to test those scenarios on your digital twin, see how it reacts, and predict how the real world supply chain might react as well. So that's a lot of talk about use cases and kind of the idea behind what you can do with IoT supply chain, and really how just the digital twin is the core of what really drives this. And that digital twin needs that connected data for you to better understand how changing different parts of that twin affect other parts or affect the real world, or how changing the real world or affects the twin. So it's really about looking at those connections there between everything. So let's see what this looks like actually in graph. So this is a very basic IoT schema. And remember that this is a schema. So each one of these vertices here represents a vertex type. So this is not, there would be multiple sensor vertices or multiple reading vertices. Here we are just representing how those different types interact with each other. So this would be a very basic one where we have a device. That device is of a certain device type. So that, this might be, say, a heart rate monitor. It is of type heart rate monitor. Status would just be a generic something like it's turned on, or it hasn't had an error. Its status is errored, it's not errored. Has a sensor. So heart rate monitor might have obviously a heart rate sensor, but it might also be able to do something like blood pressure, might be able to do something like blood oxygen. So it can have multiple different sensors within it. And those sensors, of course, have a type as well. Is it a blood oxygen sensor? And then each one of those sensors is going to have a bunch of readings. And those readings, of course, need to be stored, connected to that sensor. And here you can kind of see how at any point, we can now sort of filter down. If we want to say, find me all readings from this one device, you can do that. We can start with the device and we can just quickly traverse down the chain to any of the readings connected to it. Find me, any device, any heart rate monitor, all the readings from any heart rate monitor. Once again, that's easy, heart rate monitor through device and down. And you can kind of see how we could quickly get any of that data. And one of the other things that we need to take a look at is this next reading edge here, from reading to the next reading, because we need to maintain that relationship of time, essentially, between the readings that we take. So we need to store that edge to say, this is the next reading, this is the next point in time, because that's important. The chronological progression of these values is what's actually important and what we're after. So we need to maintain that edge to say that this is the next one. Chronologically, this is the next reading. And how do we do that in graph? And that's a little tricky. Time series information in graph is kind of a interesting topic. It's not, on the surface, it's not the most logical, but once you get into it, you can certainly make it work in a reasonable and performant way. So that really involves the usage of time trees. So that's what this image is representing. And if we just focus kind of on the left half here, this is the basic idea of a time tree, is you have vertex types that represent your different hierarchical time elements. So a month, a day, hour, minute, second, however granular you want to get with your readings. If you're only capturing reading once a minute, you don't have to go down into the second range, things like that. So what does that look like in real life? Well, that might look something like this, where we have, month 11, day 5, hour 14, minute 56, so on, are all connected to this reading. And what that allows us to do is say, get me the reading that happened at this exact time. Well, we can do that by finding all of those, but we can also say, find me any readings from November 5th, so 11/5, and then we can just get all readings from that day. It's a quick and easy traversal to do that. So we can easily filter that. And additionally, if we wanted to do something maybe a little bit more out of the box and say, get me all of the readings from noon on any day. So any reading from that has an hour of 12, well, we can get that, independent of what day it was on. We just wanted to say, what do the readings during that time typically look like? That's something that can easily be done. And this is kind of what this looks like in an actual graph with actual IoT data in it. So we can see, here's our hour vertex. These were taken at 11 a.m., at 7 and 9 minutes respectively. and 32 and 49 seconds. And each one of these readings is linked to the next reading. So that way you could follow along if we wanted to recall the information from the graph. And they're each linked back to the type of reading, a temperature reading. And this one was from a sensor located in the window. So that's just why it's called window. But we can see now kind of what this relationship looks like in the graph and how we could more easily query this. And you can get the idea of sort of how this information is linked and traversed. And this is just one sensor. Obviously, if I were to bring in more than one, it would get much more complex in here. But I can show that off. We do have a live graph with IoT data in it that I can show off if there is some time and any questions about that. But obviously, we can get a bit more advanced than that. So here we've just been talking about data collection, these sensors that collect the data. But there's so much more that's associated with any of these devices, any of these sensors. There's this whole management aspect, of course. And then there's also a side of that. What are these for? What do they actually do? So this is kind of an idea of what an expanded schema looks like a little bit with the device and some user management. There's maybe an admin user who's able to log into the device if they need to update the firmware, or if they need to check the logs or clear some sort of status. The device is in a location, it's in a physical warehouse, it's in a vehicle, it has some sort of broader location that it could be in, maybe with other devices that it could be linked to with connections of how they interact with each other. So this IoT schema doesn't just have to sit on top of the readings that you collect, but can kind of overall express the relationships between your entire manufacturing floor, your entire shipping fleet, really whatever it is, whatever ecosystem that you're working your IoT integrations into. Now we're going to get a little bit more into some of the nitty gritty. So some of the cool improvements that you can make kind of by keeping everything in the structure. So remember earlier how I was talking about how graph is kind of the idea of those pre-computed joins between your tables. And that makes it more efficient because you only compute it once when you load your data instead of every time that you run any query that might be needing that. Well, if we start looking at this data structure, we can start doing things like that as well. So if you think about what you might typically want to be doing with your data, you're analyzing it over time, you're looking at the fluctuation of your different values over time and trying to figure out what that corresponds to. Well, what you're really looking at is the changes in your data. You don't necessarily care about the actual values. You might as well, which is why you want to store them, but you're looking at that change in that data and how that might affect, that change might be different from normal and that might affect something. So we can store that information along our next reading edges. We can store that information of how reading A varies from reading B along that edge. So now when we go to do processing on that, we no longer have to do the math every single time to say, how does reading A minus reading B to get that difference? We can now pull that difference directly from the edge and make it more efficient. And additionally, if we know that we don't care necessarily about the per second data, maybe we only care about how the data changes over an hour of time. Maybe it's something like ambient temperature data, where it's really not going to fluctuate that much minute to minute, but over the course of an hour, it could have a significant change. So then you can kind of create this, embedding or this higher level reading, which represents all of the readings below it. And it can either be an average of their change, it can be some sort of embedding generated off of, each of those individual readings. But now instead of having to compute each one of those readings every time you want just an hour segment, you can just take that hour segment and have the information related to those readings. And then from there, of course, you could do that by further having that information stored in another edge between those embeddings. And you can really see now how you can generate much more efficiency by sort of pre-computing all of this information and storing it in the graph. Because essentially having these extra edges is cheap. It's just memory space that you're storing up versus the continuously having to use CPU to compute that type of information when running your queries. So that's really the bulk of it. I can pull up that demo and I can kind of poke around through the actual graph that we have running a bit. But I will open the floor up to questions if anyone wants to ask about, I guess, anything related to IoT and graph in general, or sort of other ways in which graph can be helpful. Give me 1 second to get that demo up. Sorry, 1 second, having a little trouble finding it. There it is. So this was kind of a live demo. We do have a workbook around this. So there is like a full follow along if you want IoT graph demo that we have set up that we've built out. I'll just kind of pull it up just to quickly walk through what it was doing. I built these little sensors. They're just basic environmental sensors. They capture humidity, temperature, ambient light, and they connect directly to Wi-Fi, and they just integrate those readings straight into TigerGraph. So they just connect directly to the REST endpoint where you can submit data to your TigerGraph server, and they directly upload that data themselves. Might not be the REST for the real world implementation. You probably want some sort of middleware in there just to make sure that there wouldn't be any malicious attacks, but this was just for a quick test. But eventually what was built out was kind of a web dashboard, and it had a visual aspect to represent kind of the room that the sensors were in and how the light came through the windows, and sort of how the temperature and the full monitoring of that information, and the ability to kind of project that over time, how that changed across the different sensors based on the part of the room they were in. The kind of the whole idea of the project was that in office buildings, a lot of the time you have different people in different areas, and there are different parts of the office building that are at different times of the day just empty, and others that are very full. So if you can now monitor who's in certain rooms, you're able to turn off the heat or the cooling to rooms that people aren't in, and be able to use less energy that way. Or if the sun is shining through the windows, you know that you don't need to heat that room as much because it's getting that sunlight, which is going to make the room feel warmer. So because of that, that's kind of one of the ideas of how you can build this digital twin of a building, of the heating and cooling system in a building. So that was kind of what was being explored with this demonstration, where we're capturing all of this different sensor information. But long story short, this is kind of what that looks like in graph. You might recognize this image, but we can see that all of these are readings. And if we kind of click on them, we can get some more of that information about any particular reading and a bunch of the other data in the graph as well. And what we can do with some of that, let's see what we have for some queries in here. So a lot of these are just pulling in information. Some of the things that we were working on with it is the ability to take, if we can see here, oops, let's make this a little bigger. We have areas where there was no data. So maybe one of the sensors turned off. Well, how can we use the other data in our graph to assume what that data would be from that sensor? So that's sort of the type of thing that you can look at with these relationships that we have between, we had 3 different sensors, one in a window, one on a desk, and the other was just kind of the ambient temperature. So if one of those goes down, how can we use the readings from the other 2 sensors, the knowledge of their relationship from past readings, to assume what that's going to look like? So that's something that's very possible with kind of these IoT and graph connections. So I can poke around in this demo a bit more. Again, open to questions. I see there's some coming in, so I will I'll start answering those. There are predefined way to load data into graph vertices from traditional systems like databases. Yes, so we have a bunch of different ways. So the main ways that we load stuff are just through your traditional CSV or JSON files. We do have a direct hookup to migrate from a traditional SQL database, so you can do that as well. We also have a Kafka loader So you can load in directly streaming data. That's great for IoT data, is being able to just directly stream it in through that Kafka loader in order to just directly ingest it. And we also have the ability to import from Amazon S3 buckets. So all sorts of different ways to bring your data into Graph. You just need to make sure that you have knowledge of those relationships in the data, so that way you can accurately model your schema. But yeah, there's a lot of different ways to use Graph to interface with TigerGraph. That's kind of one of the cool things I like about this product, is through the whole, this window is a very visual way to take a look at your data mapping, your schema design, and to easily go through it. But everything that you can do here, you can also do through REST endpoints. So you can do it programmatically or from another application. So it's really great to be able to just, whatever you're doing, first visually understand it through the interface, and then from that, just purely interact with it through code from whatever application you're building. Crazy. Yeah, any more questions about anything related to Graph IoT? Let's see what else we can talk about. Yeah, so it's pretty cool to see with these connections, just kind of what more information can be gathered. That's one of the things that always kind of gets me when I'm working on a Graph solution, is you always head into it, you have a problem that you're looking to solve, but you just find so much more with the data once you start poking around in it, once you start connecting things and seeing what's where. With this, we initially wanted to be able to fill in the gaps of that sensor data, or be able to kind of predict how the room would react based on the changes in the ambient temperature and lighting. But there's really just so much more data that you can then bring in, because there is all this real world data and it's happening at the same time. So you have that connection there of sort of that time frame that it's happening in, and you can easily now connect things, additional information to that, to just gain further insights. So it's always great when you kind of when you're able to find a public data set that you can use to supplement whatever your data you're working with. This one, initially, we didn't have that real world, the outside weather data, but once you're able to bring that in, now you have a bunch more information about the whole system that your sensors are interacting with. And there's no longer just the indoor that you have, but you have the outdoor as well. So it added this whole other dimension to the insights that we were able to generate from that. So that's one of the cool things that Graph can really do, not just with IoT, but with any situation in which you try to bring it into. It just gives you that further dimension of depth to all of the data that you're working with. Any TigerGraph libraries available to interact via Python? Yes. So that's actually what we're using in this notebook. This is our TigerGraph. So let me get back up to the top here. But this is our TigerGraph library, and it can all be done entirely within Python. So TigerGraph is our Python connector. We have a JavaScript connector. We have a Java connector. We have a Spark connector. We have all sorts of connectors for most programming languages. And if we don't have one for a language that you're looking for, let us know. That's kind of the responsibility of the team that I'm on, is sort of making sure that we have everything that the developer community is looking for from our product. So when we need to build integrations or connectors like that, that's what we're working with. But yeah, you can do, like I said before, you can kind of do everything either through this interface, or you can do everything through code. So this workbook actually goes through the entire solution, everything after you've set up your TigerGraph instance. After you've created the instance, this will create your schema, load in your data, map your data, and it will also include the code to install your queries as well. So everything, like I said, can be done through code, and the code is our GSQL language. So it is a new language, but it is very similar to SQL. If you're familiar with SQL, you should be able to pick up GSQL pretty quickly. It has some really cool features in it too that just make it very fun to work with, especially when working with just the vast quantity of data that is graph usually. Things like accumulators within the language are very helpful for being able to store and count that information easily within the duration of the query. Any resources where you can find notebooks? Yes, so we have a great website, developers.tigergraph.com, where we have a bunch of our learning resources. You can kind of poke around, search for individual things to get started. Here you can probably find the IoT demo that I've given in the past. So you can check that out as well. And that will have links to the workbooks. A lot of these are videos or blog posts that do then also have links out to those notebooks. We also have the TigerGraph Dev Labs GitHub repo, where we store a lot of our open source tools and other materials that you can work with. So this is where you would find, if you wanted, the source code for TigerGraph or any of our other connectors, and a lot of other TigerGraph integrations and tools. So lots of places to learn new things. We also have a YouTube channel, of course, with a bunch of educational videos as well. And yeah, Kaylee will be sending out an email, which will have a bunch of educational resources, as well as some links to kind of our 101 guides, which are very much just in 1 hour, how do you go from no graph knowledge to your first TigerGraph solution? And one of the great things, I guess I should kind of plug this, is you can use TigerGraph entirely for free. We do have a free tier, which is usually more than enough for a lot of what people are trying to use it for. That's not, industry work or, commercial work. So a lot of just the playing around, like this entire solution could be set up on a free tier, no problem. And the free tier is just infinite use. It's the only limit is the amount of data that you can put in it. It's just limited to 50 gigs of data. But other than that, it's the full TigerGraph product, free for you to use. So highly recommend, if you want to get your hands on it, just head to tgcloud.io, just create an account, and you can go ahead and set up a solution and just get started for free. We have a lot of great starter kits that you can choose from. So we have things like, let's see if I can find one that I already have set up. So we have like a supply chain starter kit, for example, and you can just go ahead, if you wanted to, just create a solution, select one of the starter kits that you'd like to go with. So where was supply chain? You select your free tier, and then from there, you would just give it a name, and you would set a password for you when you go to log in, and a domain, which you would just use to log into. So supply chain, really doesn't matter. And then from there, you would just create it. And within 5 minutes, you'll have your free TigerGraph solution. And then from there, you can start poking around in it, just like I was doing with this solution here. This one is a TigerGraph cloud solution, but we're not just limited to cloud, of course. You can download TigerGraph and install it wherever. Also, check out other graph stuff. While this is a TigerGraph presentation, graph in general is just a useful thing. So I would rather have you using graph in general than just only the TigerGraph product. So highly recommend you just kind of get familiar with graph technologies or graph thinking, and then try out whatever you want to try out. But just graph is the way of the future, really, as far as information storage and analytics is concerned. So either get involved with it or kind of get left behind is the way that things are going. So highly recommend you check out graph in some aspects. Yeah, so any more questions, anything you want me to kind of dive deeper into?
Looks like we have one more question from Brajesh, if you want to answer that in the Q&A.
Port issues on the Docker. It might depend if you have other Docker instances running at the same time that are using the default TigerGraph ports, or if you're trying to run multiple TigerGraph instances at the same time. then they might be overlapping with what ports they're trying to use. So you might just need to check your Docker configuration, or you're running Docker instances, or if you even have any other web services running that are hosted off of that laptop, you might want to check to see if they're using any of the overlapping ports with that TigerGraph Docker instance.
Tell us some more. How did you build your sensor and connect it to TigerGraph? Because I know Ford's doing, or I think Ford was doing that with some of their production, but that was really neat because I know, as IoT, how can they connect their IoT devices to TigerGraph? That was, you had that in your collab up there.
Yeah,
That's
definitely.
really fascinating because we haven't done any of those before. And so you built this from scratch. Good job.
Yeah, so this is based around a ESP32 microcontroller. It's just a relatively bog standard. Most smart devices have either an ESP32 or its younger brother, the ESP8266, which are just common Wi-Fi connected microcontrollers. So any smart device that connects to the internet has usually some variant of one of those chips in it or a similar Wi-Fi connected microcontroller. So anyone can get access to them, and it's very easy to program them with, if anyone has knowledge of the Arduino ecosystem, you can program these within the Arduino ecosystem. You just write C++ code. So I just built a very basic connector, which read those sensors and then published them to TigerGraph's REST endpoint. So all of these connectors just connect to that REST endpoint where they're able to publish that data. So really all they do is just send post requests to that endpoint with their data packets within them. So it's really very simple to get any device to connect. It was kind of a challenge for me to be like, can I get this directly from a microcontroller? But it was easy. But realistically, you would want to do this with something like a Raspberry Pi, where you could write it in Python, or a JavaScript server where you could do it from. But it really is possible even from something as low level as a microcontroller. But yeah, you could also, I don't think I had the memory space to implement a Kafka connector on an ESP32, but you very easily could use the Kafka connector if you had something like a Raspberry Pi or a device which is able to handle that. So yeah, it's very easy to do that. I would really recommend, I think the way would be something like these sensors with their Wi-Fi connectivity connect back to a host device, like a Raspberry Pi or some sort of other middleware machine. And then that posts the information to the TigerGraph server. Just so that way, if one of your sensors gets compromised in some way, it's not going to be a security risk directly to your database. Hopefully your middleware would be able to recognize that risk and not post fraudulent information back to your database. So just in terms of security, you would probably want to layer in there, but in terms of necessity, you don't need it. But yeah, really any machine, which is most of them nowadays, which has the ability to connect to the internet or connect back to a device, which then does connect to the internet, could potentially post information to a TigerGraph server. So it's very cool when you think about that, like Haley was saying, with Ford, their manufacturing machines on the actual assembly line floor could be reporting their data directly back to a TigerGraph server for deeper analysis on the performance of those machines.
Rajesh mentioned that he does it already. So are there anybody else that want to talk about the use cases that you may have, or any questions for Dan of hypothetical use cases? Because this is really neat, the different use of bringing in the hardware together to the graph, because most of it is just always graph that we talk about. So, and you did this, if you want to again talk about how you did it at one of your former companies with Fitbit data too.
Yeah. So I can kind of go over that a little bit. So I used to work at Optum, which is a large healthcare tech company. And they kind of had, which is where this actual healthcare use case comes from. But when we were there, we were looking at the correlation between one of the projects that I was on, we were looking at the correlation between members' activity level and their healthcare claims. So are people who are more active, do they cost less in healthcare? So in order to do that, we were able to look at that activity, how it corresponded to different claims, and even the different topics of those claims for those more active people. The thing we ended up finding actually was pretty interesting, where it was more active people do not cost less money. They just have more claims related to their activities. So it ended up being pretty much exactly the same cost-wise, which was pretty interesting. But yeah, it was very cool to take the healthcare data, which we had already been looking at in Graph, kind of that traditional claims data, and bring in this, IoT, this Fitbit heart rate, step count, and that type of data alongside that, and really be able to look at those together kind of for the first time. It was very cool to see some of the correlations that you could have. For example, we had a program where if you hit a certain activity goal each day, you got money back on your health insurance. So therefore people were incentivized to be active. Well, you could see things where maybe someone had a claim for a broken foot, but they still managed to log 13,000 steps every day for the next week. So what was going on there? Were they giving that Fitbit to someone else to take those steps? Were they doing something else to fraudulently generate those steps? So we could see things like that. You're in the hospital for open heart surgery. You're not walking anywhere. Why are you generating 8,000 steps? So things like that. The program wasn't evil. I just kind of want to say that might sound terrible. Like, you're in the hospital, we're not going to pay you. They had a thing where if you were in the hospital or if you were hurt, they would automatically give you your money for your activity. But it was still interesting to see some cases where that did happen, where you could be like, this person probably isn't the one wearing that Fitbit that they have linked up to their healthcare account. So yeah, there is IoT data everywhere, and it is just waiting to be integrated into the data sources that we've been using every day for the last many years to just completely open up new insights that we didn't even think to look for before. So it's a very exciting technology to be able to bring all of that data together in a way that's actually efficient and meaningful to traverse.
So how do people get started? We'll send them out the deck and we'll send them out all the resources, and then kind of to make it so it's not so overwhelming. What do you recommend? Like, maybe are the top 5 steps to get started to connect some of their devices and kind of break it down to summarize?
Yeah, definitely. I definitely recommend going through one of our TigerGraph 101 courses just to kind of get the idea of how to use the product and how to think about designing a graph schema. I mean, we did cover over that a little bit in here, designing a IoT kind of graph schema, but there's still a lot more to schema design that we didn't touch on here. But yeah, then from there, I guess as far as connecting your devices, I mean, if you've been working with IoT data before, then you already know how to get the data off of your devices by, your Fitbit API or your Apple Health API or whatever API your device might have. So then it's just getting that data into TigerGraph. So you'll just really, a lot of that's just going to be some sort of middleware, Python package or Python solution or JavaScript solution to just call one API, take that data, and then pipe it into TigerGraph via the loading API. So there might be a slight data transformation that needs to be done there just to put it in, the format that TigerGraph is expecting, where you're expressing those edges and the different attributes for the vertices. But that's really trivial work, glue code really to just, change the format of that data. Maybe it's a JSON file that needs to get converted into a CSV or vice versa. And then from there, once you start loading it in, you can just start real-time consuming your data as long as that service is running that's pulling it in. And I don't know, from there, I guess it's really about bringing in all the other points of data that you might have. You do have kind of those multiple IoT devices and you want to see the broader picture that they form. If you want to see, maybe you have a solar panels on your house and your solar charge controller is connected to the internet, and you can collect that data. You want to see how the weather or different environmental factors, air quality has an effect on the solar power that you're able to generate. All those sorts of things could easily be done with those graph connections from your IoT data set, IoT data that you're getting, and that environmental data that you can just pick up from free open source data sets, things like the weather and other data like that that's just out there for you to be able to grab.
Great. And then I think there was one other question. I don't know if you answered it from Submit. Is there a predefined way to load data and graph vertices from traditional systems like databases or files from data lake with millions of rows? Kind of.
Yeah, we kind of touched on that one with the,
Okay.
where is it? With the migrate from relational database, or just through all of the other different loading options from CSV loading, JSON loading, Kafka loader, Amazon S3 bucket. So there's more than enough ways to pipe in your more traditional data into TigerGraph in order to start generating more insights.
Great. And I'll ask one question, so if it gives people time to ask questions, but what's the most challenging thing about getting started with TigerGraph that you run into that people can be, just on alert for?
Yeah, I think the most challenging part for most people is just wrapping their head around how different graph schema is from the traditional database schema that you might be used to. It's a different way of thinking to sort of think about those relationships within your data and what should be a vertex versus what should be an edge, what should be an attribute versus what should be broken off as its own vertex, because it'll make it more efficient to query later on. So there's just a little bit of knowledge that you have to have going into it, a little bit of willingness to put back the ways that you might normally think about your data structures and think about them in a new way. So for most people, it seems like that is the hard part, is kind of wrapping your mind around how graph is different from the way that you've been doing everything for years and years. But after that, I think it's very forgiving in TigerGraph is the nice part. The schema is very flexible. So once you kind of make your schema, you can just augment it on the fly. If I wanted to add in a new edge type between readings and days, I could just do this and I could add this edge in and I could publish it to my graph and all of my data is still there. Everything's exactly there as it was before. Now I just have this new edge that I can start loading data into. If I want to remove something, same thing. I don't have to reload all of the data into my graph. I can just make that schema change and move on with my life. So while it is challenging, TigerGraph does try and make it more forgiving and easier to learn by kind of being able to easily make those mistakes, correct them, and just move on with it rather than having to, go back and forth and restart every time. So that I think is kind of the main challenge for people, is just thinking in the graph way. So.
Great. Well, thank you, Dan, so much. And everybody that came, again, follow up if you have any questions. We're so glad that you're interested in TigerGraph. And thanks for being a part of the 3-part series into Nihil, into Applied Singularity. We're grateful to be part of your session. And again, if you have any other questions, please reach out to the community or to us. And I think we're getting a developer advocate in India. So you'll have someone there that can also answer questions more quickly too. So I don't know, Nihil, if there's anything else, or Dan, you guys want to say, but thank you all so much for coming.
I saw one last question come in, so I'll just quickly address that. Is the modeling as it is, or is optimization possible? So right now there's no current like optimize my graph schema button. But one of the things that you will do, you will inherently optimize your schema on your own as you start writing queries. So for example, when I started building this out, we didn't have this next reading edge. The readings were just kind of individual, and I was going to try and parse through them by just getting the next minute or the next second within the time tree. But that just became very hard to do. So instead we had to generate this next reading edge, and there's actually a query in here to generate those edges after we have those readings. So the sensors each add their own reading, and we don't generate those next reading edges until kind of a batch process goes through. Obviously, we could change that. I could have, once a reading is posted, it could run that query automatically to generate that edge. So however you want to do it that way. But long story short, the schema, we optimized the schema by ourselves afterwards once we realized that we needed to add that edge in. So there's no automatic optimization. However, because of the flexibility, you do end up optimizing your schema as you start using your graph. So hopefully that answered that question.
Okay. Thank you, Daniel. Thank you, Kelly, for conducting this session with us. Thank you all the guests for joining in. Hope you have found this entire series quite helpful. If there's anything that you require, please feel free to reach out to Daniel or Kelly anytime to get your doubts cleared. And we look forward to having you for more sessions in the weeks coming ahead. Quick reminder again, today is the last day for, to apply for the job search support program. So if either you or any of your friends or colleagues are looking for that ideal AI job, but you're not able to crack it yet, please feel free to fill up that form. And we'll be announcing the first cohort in about a week from now. Thanks again, everyone, for joining us. Have a great weekend.
Great. Thank you all for coming.
Yeah, thanks. Have a good weekend.